Welcome back, everybody. This is our fourth session in JEE Mains previous year questions for chapter Electromagnetic Wave of class 12th. Before this video, we have made 3 videos in this series and all of those videos are available on our YouTube channel's playlist section. We have also started a similar series for NEET previous years. So if you or either some of your friends are preparing for NEET and they like to have PYQ practice, then they can also watch these videos. And if you find these videos helpful, useful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With this, let's start today's video. In the previous one, we covered up to question number here. I think this is 25th or something. That is 24th. The 25th we have already covered, and that is 26. So we will start with 26. So here, the electric field of a plane polarized electromagnetic wave free space at t is equal to 0 is given by this expression. So we have to find out the magnetic field related to it. Now to solve this question, we can see easily here that we can use that V is equal to E cross P. Let me adjust pen thickness slightly so that it can be more fine. Now here means we have not given, yes. So this whole expression can be written as like this, that E of xy is equal to 10j cos of bracket, square bracket. This will be 6i plus 8k dot xi plus zk. So from this we can find out direction of the wave, that electric field is along j direction and wave, this whole wave will be propagating along, or we can say velocity will be along this unit vector. Now we have to convert it into unit vector, so that will be 6i plus 8j by 6 square plus 8 square, and that will be 10. So this will be basically 6i plus 8j divided by 10. So that is the direction of velocity. Now we know that V is equal to E cross P. We have V, we have E, so we have to find out that what will be the value of P, or what will be the direction of P basically. Now normally what happens when we have an equation like E is equal to E naught cos of omega t plus k of x, then direction or velocity is in the direction normally minus of omega by k, and it will be in the normally negative x direction. Here we have only taken positive sign, so we will solve both for once we will solve for positive sign, and then we will also solve for the negative sign, and then we can match that which of the given option is matching properly. So let us start with this expression. Here we have V is equal to E cross P. Now we have E available with us, so what we will take? We will take cross product on the both sides with E. So this will be E cross P cross E. Now V is assuming positive side sign initially, we will get 6i plus 8j divided by 10. Cross direction of E is j. Now we are only discussing regarding direction. Now this will be a, here we will get E dot E into P, and minus we will get B dot E into E. Now we know that magnetic field and electric field both are perpendicular in case of electromagnetic wave, so this term will be 0. And As we are discussing here regarding unit vectors, electric field is along j direction, j dot j will be 1. So basically from this we will get that b unit vector will be along 6 of I cross j, that will give us k, so 6 of k plus 8 of j cross j. Sorry, we made a mistake here, that it was k, 8 of k, it was k, so it will be k here and it will be k here and it will be k here. Now k cross j will give us I with negative sign, so this will be negative 8 of I divided by 10, and this will be basically we can write it like 6 of k minus 8 of I divided by 10. So that will be the direction of magnetic field if we take this velocity as positive. Now if we take it as a negative, then we will have a negative sign here, and then we will get additional negative sign here, and from that that will become 6 of k minus of 8I divided by 10. Now let us match the given possible direction. So here we have 6 of k plus 8 of I, it will not match. Here we have 6k minus of 8 of I, it can match. Here we have 6k plus 8I, this will not match. And here we have 6k minus of 8I, this can match. So we have, we can say, uh, so any of option B or D can be a right answer. Now we have to deduce between B and D. So for that, what we can do, we can check the direction of the velocity. Now we know that this answer or this direction came when we considered velocity as positive. And if we see here in this option, we know, assuming it this term we can write it like k times some vector r. So this will this is like kr minus 10 ct, and this is kr plus 10 ct. Now, if we check sign of velocity, here it will be minus omega by k. Here omega is negative 10c, so that will become positive. So here velocity is positive. In this one, velocity is positive, and in this one, velocity will be negative. And we solve this whole expression for the positive. So negative, the term with negative velocity, the option with negative velocity will be discarded. So only option B can be right answer for this question. Hopefully you understood it well, and best of, with this, let's start the next one. So here we have an EM wave from the air enters to a medium. The electric field E1 is given by this expression in air and in medium, where the wave number k and frequency nu refers to their value in air. The medium is non-magnetic. If epsilon R1 and R2 refers to the relative permittivity of air and medium relatively, which of the following option is correct? We know that velocity of a wave, or v, in case of vacuum, that will be written as in case of air we have air and medium. So in case of air it will be under root mu a, both are non-magnetic material, so we are considering as mu node into epsilon of a into epsilon node. This is velocity inside air, and velocity inside medium will be equal to under root mu node epsilon for the medium into epsilon node. Now for air it is given to be epsilon r1, and for medium it is given to be epsilon r2. So from this we can write that for air it will be mu node epsilon node into epsilon of r1, and for medium velocity will be mu node epsilon node into epsilon of r. So now from the given equations, first for the air, we can write that E1 is equal to E01 x cos of 2 pi z by c into, here we have nu, and minus we will have 2 pi nu t. So from here this will be the omega 1, omega 1 is 2 pi nu with negative sign, and we can say k1 that will be 2 pi nu by c, 2 pi nu by c. So v1 or velocity in air, that is va, that will be minus omega 1 by k1, and that will be equal to negative of negative will become positive 2 pi nu divided by 2 pi nu by c. So this will give us c. Now similarly, for the second medium, we can say velocity of air, velocity of the wave inside medium will be negative of omega, that will be k times c or negative kc, and divided by twice of k. So that will be c by 2. Now if we divide both of these, what we will get? We will get va by vm will be equal to under root epsilon r2 by epsilon r1, and va is c and vm is c by 2. So their ratio will be equal to 2, and from this epsilon r2 by epsilon r1 will be equal to 4, and epsilon r1 by epsilon r2 will be equal to 1 by 4. So that matches with the option C here. Let us move ahead. The energy associated with electric field is UE and with magnetic field is UB for the electromagnetic wave in free space. Then we have to find relation between UE and UB. Now we know that UE, that is energy per unit volume, in terms of electric field, that is half epsilon naught E square, and in terms of magnetic field it is B square by twice of mu naught, and this is total energy per unit volume. Now we have a relation that for an electromagnetic wave C is equal to E by B, and that C is also equal to under root mu naught 1 by under root mu naught epsilon naught. So from this E square by B square is equal to 1 by mu naught epsilon naught, and suppose we are substituting for the B. So from this B square will be equal to mu naught epsilon naught into E square. So here we will get mu naught epsilon naught into E square by twice of mu naught. So mu naught get cancelled and we will get half epsilon naught E square, that is equal to UE. So both are equal, that is option D. Let us move ahead. A plane electromagnetic wave of wavelength lambda has an intensity I. It is propagating along the positive y direction. The allowed expression for electric and magnetic field are given by. So here it is mentioned that intensity is I and wave is propagating along positive y direction or J. Now we know that if intensity is I, then I by C is equal to half epsilon naught E square, and from this we can write that twice of I by C epsilon naught whole under root is equal to E. So this must be the maximum value or amplitude of the electric wave, and if we match it, then it only matches with here option C and option D. So A and B are cancelled, and if we look closer into both options here, from this expression inside the cos, we can find out that direction here will be positive y direction, and for this one direction will be negative y direction, and as mentioned that wave is along positive y direction. So option C will be the right one and D will be wrong here. Let us move ahead. A monochromatic beam of light has a frequency given by this value and propagating along direction. The velocity is along this direction, polarized along k direction. Now polarization means direction of electric field, the acceptable form of the magnetic field. So we have to find acceptable form of the magnetic field. So we know basically that electric field is perpendicular to magnetic field and they are also perpendicular to the velocity. And we also know that v in direction is equal to E cross B. Now velocity is here I plus J by 2, and electric field is along here K, so K cross B. Now what we can do here, we can take cross product of both of these sides with K, because we know its value, so it will be I plus J by 2 cross K will be equal to K cross B cross K. Now from this side we will get I cross K, that will be uh, basically K cross I is J, so it will be minus J, and plus J cross K, this will give us I by 2. Okay, it was root 2, so it will be root 2 and root 2. And from this one we will get only B, so this will be the direction of B, so that will be I minus J by root 2. And if we see it, so option C is cancelled because here magnetic field is along K, and option D is cancelled. Here magnetic field direction is this one. So we have only option A and B that are possible here. Now, uh, what we can do further? Now we can look up the direction of the wave. Here direction of the wave is I plus J by root 2. In the option A, direction of wave is we are getting, that is I minus J by root 2, and here option B we are getting I plus J by root 2. So option A is rejected and only option B is left as a possible answer. Let us move ahead. The electric field component of a monochromatic radiation is given by this relation. We have to find magnetic field component. Now, this wave is forming a standing wave. So if we have electric field in the form of both causes, means cos kx and cos omega t, then magnetic field will be in the form of both signs. So it will be sin kx and sin omega t. Now, so from that option B and D are cancelled, and we have only option A and C that are possible. Now from those, if we look clearly, okay, option A is also cancelled because here we have cos omega t. Both should be in the sine form. So only option C will be the right one here. Moving ahead, magnetic field of a plane electromagnetic wave is given by this relation. Expression corresponding to electric field will be. Now here, first of all, the answer must be in the sine form and sine kx plus omega t. So here we have kx plus omega t, kx plus kx, and so option D is rejected. Now further, we can find out the magnitude. We know that C is equal to E node by P node. So from that, E node will be equal to CB node. So here we have CB node, here we have B node by C. So option B is cancelled, and here we have CB node. Now the only part remaining is the direction. So direction, the wave is propagating along negative x direction. So minus of I should be equal to E cross B, and direction of B is J. So J. Now we have to substitute here K, and we know that K cross J is negative I. So E is along K. So we will get positive value, and here we are getting negative sign with the K in option C. So that is also rejected. So only option A is the right one here. Let us move ahead. So here consider electromagnetic wave propagating in vacuum. Choose the correct statement. So here wave is along vacuum. So let me slide it down slightly. Now for a EM wave, basically, let me zoom it slightly so that it will be, it has a better visibility. Now for a EM wave, we know that electric field is perpendicular to magnetic field, and both are perpendicular to velocity also. So for a option here, uh, option A, wave is propagating along positive y direction. So, and we can also write that V is equal to E cross B. So in the option A, wave is along positive y, so it will be positive of J. And electric field is along Z, yani means K, and magnetic field is along Y. So if we look here, that wave is along Y and magnetic field is also along Y, it is not possible. So option A is rejected. Now in option B, here we have wave along Y and electric field along also Y. So this is also rejected because they cannot be in the same direction. Now for the option C, we have wave along X, electric field along Y plus Z, and magnetic field along Y plus Z. So again, here electric and magnetic field both are along the same direction. So C is also rejected. And if we look in the option D, we have wave along X, electric along Y minus Z, and magnetic along Y plus Z. So it can be a possible answer. So only option D is left here. So option D is the right one. Now in the next one, for a plane electromagnetic wave propagating in the Z direction, which one of the following combination gives the correct possible direction of E and B field respectively? So we have given four options for E and B, and we know for a for a EM wave, that value or direction of velocity is given by E cross B. Now here V is along Z direction, so V is along K, so it must be equal to E cross B. Now let us solve it one by one. So this is I, J, K. For the first option we have, and we will have 0, 0 here. For the first one we have electric field along 2, 3 and magnetic field along 1 and 2. And from that we know that I and J components should cancel out each other. So if we take I here, so I will be 3 into 0 into 2 into 0, so I will be 0 minus J, and if we take J here, so that will be 2 into 0 and 0, so this will be 0. And if we take K here, so that will be 2 into 2, 4 minus 3, so that is K. So option A is right. Now let us check for option B. In option B, we have negative here and negative here, and this is 3I minus 2. So 3 minus 2, and let us clear this one. So let us start now. So here I and J will be 0. Let us only solve for the K. So for K, we will have 2 into 2, that is minus 2 into minus 2, that is 4, and minus of 9. So that is also given us 13K, means we have to only look for the direction. So it can, option B can also be a right answer. We have to look for another criteria also, and that criteria is E dot B should be 0. For electric and magnetic field, both are perpendicular to each other, so their dot product should be 0. Now we are only checking for the first one, that we are only looking for their cross product. So let us also look via dot product. So for the first one, dot product will be 2 into 1, that is 2, plus 3 into 2, that is 6, so that will give us 8. So dot product is not 0, so option A is cancelled. For the option B, we will get dot product as minus 6 and plus of 6, that is 0. So option B fulfill both of the criterias. And let us check for this one. Here 4 into 3 into 4, 12, and minus 12, so this is also 0. And this will be 2 and minus 2, this is also 0. So we have to look for the direction here in both of remaining cases. So for that, let us clear this and let us check for the direction. So for 3 4 0, that is electric, and magnetic 4 minus 3 0, if we check the K component here, we will get minus 9 minus 16. So this component will be negative. And similarly for option D, k component will be negative. So both for option C and D, direction is in the negative k direction, where it is, as per the question, it is in the positive k direction. So both C and D gets cancelled. So only that only option left, that is option B here. Now let us move ahead. So an electromagnetic wave traveling in the x direction has a frequency given by this relation and electric field amplitude of 27 volt per meter. Find from the options given below which one describe the magnetic field wave. So we have to find magnetic field. So first let us check for the magnitude, that we know that C is equal to E by B, and for that B will be equal to E by C. Now E is 27 and C will be 3 into 10 raised to power 8. So this will be 9 into 10 raised to power minus 8. So option A is cancelled and magnetic field amplitude is wrong here. And in B, C and D, in all these magnitude is same. So let us check for the further. Now wave is traveling in the positive x direction. So if wave is traveling along the positive x direction, here in all of these options wave is traveling along the positive x direction. Now further what we can check, we can look for the velocity. So velocity will be equal to minus of omega by k. So for the first one, assuming this is 10 raised to power 14, so what we will get, 2 into 10 raised to power 14 divided by 1.5 into 10 raised to power minus 8. So this will be uh, this has to be positive. So it cannot be negative, because if it is negative then this velocity is going beyond c, so that cannot be possible. So it should be positive in all the options, it should be positive. So now assuming it is positive, so from that what we will get, this is positive. So wave velocity will not comes out to be 3 into 10 raised to power 8. So here this is rejected, option B is rejected. Now if we look at the option C, then what we will have, we will have 2 into 10 raised to power 14 divided by 1.5 into 10 raised to power plus 6. So this will be 20 by 15, that will be 4 by 3 into 10 raised to power 6. So it looks like our previous assumption or our initial assumption was wrong, that wave is moving with c. So for that let us correct this one, that let us not assume that it is moving with c, we assume that it is moving with some velocity v. Now if it is moving with some velocity v, then it has to travel in a positive x direction, and for that all of these are negative, so means all of options are possible. Now coming to the frequency, so a normal equation should be like this, a normal general standard equation will be like this: sine of kx minus of omega t, and this can be written as sine of 2 pi x by lambda minus 2 pi into frequency into t. And if we look here, frequency is mentioned 2 into 10 raised to power 14. So this should be like 2 pi into here we have 2 into 10 raised to power 14 into t, and here we have 2 pi x by lambda, and here sine. So if we take it further, so it will be sine 2 pi x by lambda minus of 2 into 10 raised to power 14 t. So equation should be either in this form or either should be in this form. Now if we look for the option A, so this is in the second form, so it can be right. If we look at option B, it is also in the second form, so it can be right. If we look at option C, it is in the first form. Here it should be in this form, and here 2 pi is missing, so option C is rejected. Now from this, option D can also be right. Now further let's check for another thing. as mentioned that wave is traveling along x direction, so magnetic field cannot be along x direction, and here magnetic field is along x direction. So option B is also now rejected from this criteria. And now coming to the magnitude. So here we have both of these expression as same. Actually velocity is also going to be different here. Here we have 1.5 into 10 raised to power minus 8 and 2 into 10 raised to power 14. And here we have 1.5 into 10 raised to power minus 6. And this will be 2 into 10 raised to power 14. Now, it has to be a positive sign because else velocity will exceed speed of light. So assuming it to be positive. So in the first case, our velocity will be 2 into 10 raised to power 14 divided by 1.5 into 10 raised to power 8. So that will be 20 by 15. So 4 by 3 into 10 raised to power 6. And in the second case, here we have 6. So that will be 4 by 3 into 10 raised to power 8. And we know that speed of light, and from that we can calculate the magnitude. So let us check for the magnitude. We know that V is equal to E by P. Now assuming first one is correct, so we will get 4 by 3 into 10 raised to power 6 should be equal to 27 by P. And from this B comes out to be 27 into 3 by 4 into 10 raised to power minus 6. And this will give us around, we can say 4, approximately 8 assuming. So this will be 24 into 10 raised to power minus 6. That does not matches well. Let us check for the second one. Here we will have 4 by 3 into 10 raised to power 8 is equal to E, that is 27 by P. So from this we will get B is equal to 27 into 3 by 4 into 10 raised to power minus 8, and that will be around 24 into 10 raised to power minus 8. So it has a better match here. Here power is matching, only amplitude is slightly variable. So we can say approximately, if you use approximation here, then option A is also rejected, and then only viable option is option D. So option D is the right answer here. Hopefully you understood it well. And for this video, we end it here. And if you have any doubts or suggestions, you can put them in comment section. I will try to resolve them. And if you like these videos, then do press the like button, share them as much as possible, and subscribe to channel. Thank you.